Welcome back, guys. So today we're going to continue our study on solving quadratics. And today we're going to look at our special cases. So remember, we started with factoring. When we were in our module on factoring, we started with a is equal to 1, and then we progressed to where a is greater than 1 and our special cases. So today we're going to look at solving quadratics where a is greater than 1 and also when we have our special case polynomials. Okay, so the first thing I want to look at is I want to solve this quadratic equation, 3x squared plus x equals 6x plus 2. Now remember, whenever we're solving a quadratic equation, we need our right-hand side to be 0. So the first thing we want to do is we want to make the right-hand side equal 0. Okay, so I'm going to manipulate my, my equation. So I want to subtract 6x from both sides, and so I get 3x squared. Remember, this is 1, so this will be negative 5x equal to 2. And then I need to do one more manipulation, so I'm going to subtract 2 from both sides. And so I get 3x squared minus 5x minus 2 equal to 0. All right, and now I'm ready to factor and solve my equation. All right, so now we see that a is greater than 1. So remember, when a is greater than 1, we need to find the factor pairs of a times c. So in this case, a times c is 6. So we got 1 and 6 and 2 and 3. And so I need a sum of negative 5. So I'm going to choose, here you have to be careful, because we could use negative 6 and 1, or we could use negative 2 and negative 3. If I use negative 2 and negative 3, then my ending, my c should be positive, which is not. So here it's negative, so we're going to use negative 6 and 1. And so I'm going to replace that in my equation. So I'm going to have minus 6x plus 1x minus 2 equal to 0. I'm going to factor by grouping. Okay, and I'm going to pull out my greatest common factor. Okay, so here is 3x, so I get x minus 2. And here it's 1, so I get x minus 2. And so I get 3x plus 1 times x minus 2 is equal to 0. Okay, and now we want to utilize our zero product property rule. So we have 3x plus 1 equal to 0, or x minus 2 equal to 0. Now, again, we have two linear equations that we need to solve. So I'm going to solve this one first. So I have x is equal to 2. And then if I solve this one, I get 3x equal to negative 1. And so therefore, x is equal to negative 1/3. Okay, so if I want to write my solution, remember I have to write my solution set, which is negative 1/3 2 inside the squiggly brackets. Another example. Now let's look at our special cases. Okay, so remember, our special cases are if we have a difference of two squares or if we have perfect trinomials, perfect square trinomials. First thing we want to do is we want to look at 4x squared minus 24x plus 36 equal to 0. Here we already have our right side equal to 0. So we're going to pull out our GCF. So I get x squared minus 6x plus 9. And then I'm going to factor. So I need 3 and 3. So minus 3 minus 3. And remember, I can write this as x minus 3 squared equal to 0. Now remember, we went over how to solve this in the very first lesson. We're going to solve it by just like an equation. So I'm going to have x minus 3 squared equal to 0. 0 divided by 4 is 0. And I'm going to take the square root of both sides. Okay, and so I get x minus 3 is equal to 0. Remember, whenever we have a square root, we are supposed to put the plus or minus, but there is no plus or minus 0. So we just put 0. And now we solve this, and we get x is equal to 3. So here, this example is a little weird, right? Remember, whenever we're solving quadratic equations, we expect two solutions. Here we only have one solution. What that means is, even though we have two binomials here, both of these binomials have x equal to 3 as a solution to it. And so what it means is that how we refer to that is we have a solution x equal to 3 with multiplicity of 2. Okay, so multiplicity means that this solution occurs twice. Okay, and so the way I would write this in set is I would just do curly brackets and 3, and you'd have this is called a singleton set. Okay, our last example. So here we have a difference of two squares. So this was a perfect square trinomial. Here we have a difference of two squares. So remember, to find the difference of two squares, we take the square root of 9x squared. And the square root of 36. And so this is 3x and this is 6. So we have 3x minus 6 and 3x plus 6 equal to 0. And so we get 3x minus 6 equals to 0, and 3x plus 6 equals to 0. And when we solve this, we get 3x equal to 6, so x is equal to 2, or 3x equal to negative 6, sorry, that should be negative 6, and so x is equal to negative 2. So we get a singleton set of negative 2 and 2. An alternate way that I could have solved it is I could have pulled out 9 and 36 share a common factor of 9. So I could have pulled out a 9, and I would have had x squared minus 4 equal to 0. And then factor here, I get x minus 2, x plus 2. And so 9 can never be equal to 0. So we know we disregard that solution. And so we get x minus 2 equal to 0. X plus 2 equal to 0, and so we get x equals 2 and x equals negative 2, and we get the same solution set. Okay, and that is the end of today's lesson.